Okay, today we're going to talk about solving polynomial equations. Solutions can be rational, irrational, or imaginary. Rational are numbers that can be written as fractions, like -3 can be written -3/1, 2 can be written 2/1, 1/2 is already a fraction, the square root of 4 is 2, 2/1. Irrational numbers are numbers like pi, square root of 2. These are never-ending decimals, and they're non-repeating. And then imaginary are numbers that can't be represented in any way, like the square root of -4. Well, it can't be negative, but we do have solutions with them, so we call them imaginary, use the letter I to represent them. Okay, first of all, we're going to talk about the rational root theorem. Those of you that are going to go on to pre-cal, this is important because when you're solving polynomials and you need a start, this is the theorem you're going to use to find out what is a factor of a polynomial to get started when you have to use division to start. So a polynomial has integer coefficients, which means positive and negative whole numbers. Then every rational zero of p is in the form of p over q, where p is the factor or factors of the constant coefficient and q is the factors of the leading coefficient. So here the constant is 6 and the leading coefficient is 2. So you can make a list. These are all, this instead of being able to divide infinitely number of times, this will reduce your number of times you have to divide. So you're going to take the factors, the things that multiply to 6. So 1 times 6 and 2 times 3 are the factors of 6. And then 1 times 2 are the factors of 2. Now we have to represent the positive and negative, so that list is going to be 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1 is 3, 6 divided by 1 is 6, 1 divided by 2 is 1/2, 2 divided by 2 is 1, already written, 3 divided by 2 is 3/2, 6 divided by 2 is 3, and the only thing we have to add to these is this is positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6, positive and negative 1/2, positive and negative 3/2. You did this in Algebra 2, and I just want to reiterate that this is for some of you. If you're going to calculus, this is what you have to remember on how to solve a polynomial. For this year, we're going to use calculators to get started. Okay, now we need to talk about division. Division is how sometimes you have to start breaking down a polynomial into something, one that factors or gets it down into its simplest parts. So we're going to start off with long division. You're going to write the dividend in standard form, which means in order from the highest power to the lowest power, and fill in any missing terms. And we're going to write the division like we would long division, and you're going to divide. Now, the thing to remember is long division is used when divisor, which is the denominator, or the second number like x squared minus 3, has a degree greater than 1. So this x squared is definitely degree greater than 1. Okay, so now we're going to divide. I've got to take that x squared minus 3. Now it's missing the 0x. Some people like to put this in. You don't have to, but some people like to. And now I look here, I have a degree of 3, a degree of 2, I'm missing a degree of x, and I have a constant. So I'm going to write 2x cubed minus x squared plus 0x, because I don't have any x's, plus 25. Now when we do long division, we focus on the front of the the divisor, only on that, and then just the front of the dividend, the number inside. It's all we focus on, and then the rest follows. So I think, what could I multiply x squared by to make it 2x cubed? So x squared times what is 2x cubed? Well, I need a 2 because it has a leading coefficient, and I need another x. So now what you're going to do is you're going to multiply that 2x times everything here. So 2x times x squared is 2x cubed. 2x times 0 is 0x squared. 2x times negative 3 is negative 3x. Now the thing you have to remember is when you draw this line, you have to change all the signs because you're subtracting. You're subtracting a polynomial, so you're distributing a negative. I just say draw the line, change all the signs. This leading coefficient will always add to nothing. And now I come down and say, okay, negative x squared plus 0 is negative x squared. 0 plus 3x is 3x plus 25. Now I start all over again. I'm only focusing here and still that x squared. So x squared times what is negative x squared? Well, that has to be negative 1. Now I multiply everything over here by negative 1. So negative 1 times x squared is negative x squared. Negative 1 times 0 is still 0. And negative 1 times negative 3 is positive 3. Remember, we're going to draw our line and change all the signs. So this gives me 3x plus 22. X squared has a higher power, so I am done. So my quotient is 2x minus 1, and then we're going to take the remainder, 3x plus 22, and we put it over the divisor, which is x squared minus 3. And that is long division. Now, sometimes people like to use long division when we have a coefficient in front of the divisor, like that 3x. This does have a degree of 1, and I can divide by the root and use synthetic division, but it would be a fraction. So I'm going to do it this way. So I'm going to show you 3x plus 1, power 2, power 1, constant, so I'm not missing anything. So 15x squared plus 8x minus 12. Remember, we're concentrating on the front of 3x and this 15x this round. So I'm thinking 3x times what is 15x squared. So 3 times 5 is 15. X times x is x squared. So now I have it. Now I'm going to multiply it by both terms over here. So 5x times 3x is 15x squared. 5x times 1 is 5x. Remember, we're going to draw the line, change all the signs. And now I get 8x and a negative 5x is 3x minus 12. Now I start all over again. Focus on the front and the front. 3x times what is 3x? Well, it's 3x, so I need a 1. 1 times 3x is 3x. 1 times 1 is 1. Don't forget, even on the last, draw your line, change all your signs. This is negative 13. So this solution is 5x plus 1 plus a negative 13 over 3x plus 1. And that is my long division. Okay, so now we're going to talk about synthetic division. You can only use if the divisor has a degree of 1. All the powers must be written. If a term is missing, we're going to use 0, just like we did with long division. So I have the coefficient in front of x to the 4th is 1. I'm missing x to the 3rd, so I put a 0. The coefficient in front of x squared is negative 10. The coefficient in front of x is 2. The constant term is 5, so first thing that we notice, and we write those down in our divisions. Then notice that this is in factored form at -3, but I'm going to divide by the root of 3. So make sure you make note of that, because that's where one of the mistakes will always happen. Then what we do is, once we get those coefficients written, we drop down the very first term at 1, we multiply, and then we bring it up. So 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. -10 plus 9 is -1. 3 times -1 is -3. 2 times -3, 2 plus -3 is -1. 3 times -1 is -3. 5 plus 3 is 2. Now, a couple of ways that you can do this, but I usually remember the last number's remainder. This is the number, the constant. This is the coefficient of x. This is the coefficient of x squared. This is the coefficient of x cubed. So now I write my 1x cubed plus 3x squared minus 1x minus 1, remainder on top of the divisor. So that's how we do it. Okay, so now let's do some division. I have a degree of 1, so I can use synthetic division. I'm going to use the root, which is -2. I've got a power of 4, a 3, x squared is missing, so the 2, the 1, the 0. So I put the 3, the -1, 0 for the missing term, the 5, and the -1. I drop down the 3. -2 times 3 is -6. Add them together. -2 times -7 is 14. Add them together. -2 times 14 is -28. Add them together. Oops, 23. And -2 times 23 is 46. Add them together. So there's my division. Now I've got a remainder, a constant, an x squared, an x cubed. I also know I'll drop a degree, so since this starts with x to the 4th, I'm going to start with x to the 3rd, so you can start it either way. So I have this answer is 3x cubed minus 7x squared plus 14x minus 23 plus 45 over x plus 2. There's my synthetic division. Okay, this next one, I have an x minus 2 as a factor, so I'm going to divide by +2. I have a 3, I'm missing x squared. I have an x and a 5, so a 1, a 0, a -3, and a 5. I drop down the first. 2 times 1 is 2, add them together. 2 times 2 is 4, add them together. 2 times 1 is 2, add them together. Remainder, constant, x squared. Again, it dropped 1 degree from the start. So this answer is x squared plus 2x plus 1 plus 7 over x minus 2. Okay, so we can use synthetic division for a couple other things, and one is the remainder theorem. And the remainder theorem says if you divide a polynomial, the remainder will be the answer of the function evaluated. So I'm going to show you the way we first learned it. The old way, which I call plug and chug, says everywhere there's an x, I'm going to plug in the 5. So we would do 4 times 5 squared minus 16 times 5 plus 9. So 4 times 25 minus 80 plus 9. 100 minus 80 plus 9 is 20 plus 9, which is 29. So the function at 5 is 29. The synthetic division way would be I would divide by it. Well, that is a root. That is 5. So I've got a degree of 2, 1, 0. So 4, -16, 9. 5 times 4 is 20. Add them together. 5 times 4 is 20. And so the function at 5 is 29. So this is how synthetic division is used, and this is how the remainder theorem works, is the remainder is the solution to that evaluation. Okay, so here's an example of how to solve. I have a polynomial. It is a fourth degree. It doesn't factor to start off with, so I've got to start with division to get it started. And we're going to use this rational root theorem. Keep in mind, you may use a calculator instead of this to get one root to get started. Okay? So I'm going to list them, and I have got the factors of the 6, which are 1 times 6 and 2 times 3 over 1 and 2. So this is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, and plus or minus 3 over 2. So as I go through and do this, for those of us, we're looking for a remainder of 0, and I'm just going to kind of show you what I would do is I would start off with my 1 and divide and see if I get a remainder of 0. Take my coefficients, 2, 1, negative 13, and 6. 1 times 2 is 2. 1 times 3 is 3. I can already see it's not going to work because I get negative 4. That one doesn't work. Now I go to my negative 1. 2, 1, negative 13, 6. Drop down. 1 times negative 2 is negative 2. Negative 1 times negative 1 is positive 1. And negative 1 times 12 is 12. This again does not work. Now we're going to move over to another number, and I'm going to move to 2. So I've got the 2, the 1, the negative 13, the 6. 2 times 2 is 4. 2 times 5 is 10. And 2 times negative 3 is negative 6. I got the remainder of 0, so that is one of my solutions. That is worked because I got a remainder of 0. So I know one of my answers is x equals 2. Now what happens a lot of times is you're going to end up with a quadratic that's factorable. And if it's not factorable, then we would use our quadratic formula. But I've got 2x squared plus 5x minus 3. 2 times negative 3 is negative 6. The factors of negative 6 that give me 5 are positive 6 and negative 1. I'm going to split my middle into 2x squared. Order doesn't matter. Minus 1x minus 3. Factor by grouping. The first two have a 2x in common, leaves me x plus 3. Bring out that negative 1, and now that is x plus 3. We did it right. So I have 2x minus 1, x plus 3. So now I take those factors and solve them. This becomes 2x equals 1, so x equals 1/2. This is x equals negative 3. I have a degree of 3. I found 3 solutions. Okay, so this one is a degree of 4, so I know at the end I'm looking for 4 solutions. I'm given a factor to start with, so that means that's what I'm going to start dividing by. I look at my polynomial, degree of 4, 3, 2, 1, 0. Nothing is missing, so that means I can divide. I do that negative 1. I've got a 1, a negative 1, a negative 5, a 3, and a 6. Remember, I have to get a remainder of 0, and if they give me a factor, I should. So I bring down that 1. Negative 1 times 1 is negative 1. Negative 1 times negative 2 is positive 2. Sorry, interrupted. Negative 1 times negative 3 is positive 3. Whoops. So that's 6. Negative 1 times 6 is negative 6. There's my remainder of 0. Now, I've factored forever, so I can see this thing factors. So I'm going to write x to the third minus 2x squared minus 3x plus 6. I'm going to factor this one by grouping. These first two have an x squared in common, leaves me x minus 2, minus 3, x minus 2. So x squared minus 3, x minus 2. So now I take each of those factors, x squared minus 3 and x minus 2, and solve them. I'm going to add the 3 and square root both sides. Don't forget that plus or minus. And then add that 2. So my solutions here are the -1 that I got was given, and then the positive and the negative square root of 3, and then the 2. So to go back, remember a degree of 4. This is one solution. This has 2, a positive root 3 and a negative root 3, and 1 here. That adds up to 4. I found all 4. Okay, so this one is also factorable. So factors of 36 that subtract to -5 are going to be negative, wrong pen again, is, -9 and positive 4. So I have x squared minus 9 and x squared plus 4. I can take each of these and set them equal to 0 because they're small quadratics. I'm going to add the 9 and then square root both sides. Don't forget the plus or minus. Whoops. Don't forget the plus or minus. I am going to subtract that 4. And now when I square root, I'm still not going to forget the plus or minus, but square rooting a negative is imaginary, so that's 2i. So my solutions are plus or minus 2i and plus or minus 3. And so 2 of them here, the positive 2 root I and the negative, and the positive and negative 3. So there's 2 here, 4 total. Okay, so this last one does not factor. And this is where I would do like all the factors of 10 over 1 to find the rational root. So plus or minus 1, plus or minus 2, plus or minus 5. So let's start with that 1. Again, you can use your calculator to determine what those roots would be. So I have a 3, a 2, a 1, and a 0. So let's start with that 1. 1, -4, -7, 10. 1 times 1 is 1. 1 times -3 is -3. And 1 times -10 is -10. Works out great. I got 1 to start off as one of the solutions. Now that's x squared minus 3x minus 10. This one happens to factor. If not, I will use my quadratic formula. Factors of 10 that give me -3 are -5 and positive 2. So this becomes x minus 5, x plus 2. So x minus 5 equals 0, x plus 2 equals 0, x equals positive 5, x equals -2. So now I'm going to go and put my solutions in. I've got a -2, the 1, and the 5. Degree of 3, I found all 3 real solutions. Okay, this one is a difference of cubes. So if you don't remember this, you do get one real root. You can do division. You'd have to put in the x squared and the x as zeros and long divide. This thing does factor into x minus 2 and then square the first. So that's the first. Change the sign to plus. Multiply x times 2 is 2x, and square the last, which is 4. So I already have one solution at x minus 2 equals 0, so that is x equals 2. Now, this quadratic you get when you have a sum or difference of cubes, it's either quadratic formula or complete the square. I'm going to complete the square because the b term is even. So complete the square. I move my c value over. I leave the blanks to take half the b and square it. So half of 2 is 1. 1 squared is 1. Add 1 to both sides. This is a perfect square trinomial that factors. Then I'm going to square root both sides. Don't forget the plus or minus. Then when I subtract that 1, it comes in front. So this gives me x equals -1 plus or minus I root 3. Those are the two imaginaries. So there is my solutions. And there's 1 at 2, and there's 1 plus I root 3 and 1 minus I root 3. There's 3 total there. Okay, so this next one, I see they all have a common factor of 3x. I'm going to pull that out first. And that gives me x squared plus x minus 3. So 3x equals 0, x equals 0. So there's one solution of x equals 0. Now what's left doesn't factor, so I'm going to have to use my quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So -1 plus or minus 1 plus 12 is 13 over 2. That doesn't simplify any, so there's my other two solutions from the quadratic. And now the last one. I'm giving you a factor, so we're going to start off. So I already know that one of the solutions, whoop, I did it again, I keep doing that, is x equals -2. So -2, 4, 3, 2, 1, 0. I have all my coefficients. So drop down that 2. -2 times 2 is -4. Add them together. -2 times -2 is +2. Add them together. -2 times -4 is +8. Add them together. -2 times 2 is -4. There's my remainder. So I have 2x cubed minus 1x minus 4, x squared minus 4x plus 2. Factor by grouping. X squared in common leaves me 2x minus 1 minus 2, 2x minus 1. So I have factors of 2x minus 1 and x squared minus 2. So 2x minus 1 equals 0 and x squared minus 2 equals 0. Add the 1, divide by the 2. So x equals 1/2. Add the 2. Square root both sides. Don't forget your plus or minus. So x equals positive negative root 2. I have 1 here, 1 here, 2 here, 4 total, degree of 4.